solve this linear system. We have equation 1 and equation 2. And our first step is to solve the equation for one of its variables. And looking at equation 1, this is a great candidate because it has a coefficient of -1. However, if we look at the second equation, we can see that y is already solved for. Right? So let's go ahead and use this one here. Y is solved for, so step 1 is done. Step 2 is to substitute in this expression for y, the 2x minus 3, in the place of y in the first equation. So what we're going to get is 2x minus parentheses 2x minus 3 equals 8. We'll go ahead and distribute out that negative sign. And since it's negative times a positive, it's going to be negative 2x. And negative times a negative is going to become positive 3. So what we're left with is 2x minus 2x plus 3 is equal to 8. Okay. We'll combine our like terms, and we'll get 3 is equal to 8. Now, if you ever end up in this situation where you have constant is equal to constant, we have two possibilities. Either the equation is going to be true, or the equation is going to be false. This one here is obviously false, and so our answer is no solution. To put a box around that. Now, what does this mean that there's no solution in terms of a graph, in terms of a visual representation of these two lines? Well, in the previous chapter 6.1, we saw that there was no solution when our lines were parallel and they never intersected. Okay? And that's what's happening here. If you end up with an equation that is not true, there's no solution, which means that this line and this line are parallel and never intersect. Now, if the equation is true, and it ends up with something like 8 is equal to 8, a true statement, then what that means is that both lines, that first line and the second line, are the same line. Right? And that means every point on the line is a solution. The two lines cross on every point of the line. And so in that case, there'd be an infinite number of solutions. Right? So anyhow, in this case, no solution.